Okay, we are rolling. Everything looks good. In slot 1 today, this recording completely failed, but seems to be going now. Okay, so we are doing this lesson here. It says 7.5, solving quadratic equations by factoring. So we're going to go way back in the Wayback Machine of your math education. Let's talk about the first time you saw this in grade 8. In grade 8, you'd have seen an example that said, it probably said one of two things. It either said expand or it said simplify, one or the other. And it gave you something like this. Yep, jot this one down. So your grade 8 teacher taught you that what do you do with that? You times both things in the bracket by 2. So this expands to 6x minus 10, right? Here, let's do an uglier one. Let's say that we had the thing outside the bracket isn't just a coefficient, it isn't just a numerical coefficient, it also has a literal coefficient, which means it has a variable. And there's a negative involved too. So there we go. That would be a tough one for grade 8 students. It's tough for you? Well, grade 8 was a while ago. Give yourself a break. All right, so what do you get for this one? Negative 6x squared, and then careful with the next term. Plus 3x. How come it's a plus? Because it's a negative times a negative. All right. Now, sometimes, I don't know that I should be recording myself saying this because this, I don't know, but sometimes I question the way we actually approach teaching math. I think to myself, could you imagine if we taught other subjects this way? Oh, you know what? It kicked me out of my program again. Okay, I'm going to go back. No, it says I'm recording. Weird. The little red button is gone. Okay, all right, I'm going back. All right, it says I'm recording. I'm going to check back again. Now I'm paranoid. Says I'm recording. Okay. Anyway, the point I was about to make, could you imagine what it'd be like to learn music if your music teacher had said, okay, we're going to learn how to play this note. Next year, we'll have a song that uses that note. That's kind of how we teach math sometimes. That's where we stop in grade 8. It's like, okay, thanks. Well, what's that for? Well, in grade 9, you usually had a question like this, say, a piece of algebra where if you don't know how to do the distributive property, here, I'll just use the same one. You're stuck. So if it says simplify this, if you don't know the distributive property, you're stuck. So you learned how to do distributive property in grade 8. You didn't really use it in actual algebra. You didn't get to use it in battle until grade 9. So it's kind of, again, like, oh, we'll teach you how to do this year, but we'll show you what it's for next year. That's oddly how we approach teaching math. I don't know. It's just the way it is. Okay, so what would I do with this? Well, I'd expand that. So 2x times 4x is 8x squared. 2x times negative 3 is negative 6x. Careful, most people look at that and say, well, that's a subtract, but it's also the negative that belongs to the 3, right? So it's negative 3, and we just saw that. It's the same one we just did up here. So it's negative 6x squared plus 3x. That right there, I should highlight that. That's the most common mistake people make in algebra till grade 12, even in the pre-cal program and intro calc and stuff, is they lose track of a negative when they're distributing it. It's such an easy mistake. I do it once in a while. It's an easy mistake to make. Okay, next. What are my like terms? What can I collect here? Can I add them all together? They all have x. Can I add x squareds to x's or subtract x's from x squareds? The answer is no. They're only like terms if they're the same degree. So I can add the 8x squared to the negative 6x squared, and I can add the negative 6x to the positive 3x, but then the game's over. It said simplify. Well, that's as simple as I can make it. But once again, you stopped there. That's it. That's all you learned how to do with that in grade 9. And in grade 10, you didn't even really expand on that. Well, this year you do. First of all, before we go any further that way, let's do the next level of distributive property, because you didn't see distributive property again until, well, again, you learned how to do it in grade 8. In grade 9, it got used like this. Then in grade 10, we asked you to expand, or again, you could say expand or simplify, whichever way you want to call it. We asked you to expand ones like this. And then we even gave it a special name. A name that kind of tells you what the process is. Do you remember what the name is? Remember that word? Oh yeah, okay, I'm getting some recognition now. It's really the distributive property twice. You have to distribute x into the second bracket and -3 into the second bracket so that you don't lose track of any of those distributions. We often said FOIL. F stood for first times first. So x times x is x squared. No, you never did with your teacher? A lot of teachers use FOIL. O stands for the outside times the outside, which is -5x. I stands for the inside times the inside, which is -3x. Do you get where these two numbers came from? This number times this number, and that number times that number. There's the O and the I. And then L stands for the last thing in the first bracket times the last thing in the second bracket. Careful, plus 15. Yeah, you always got to watch signs. And then again, can I add them all together? No, only two of them are like terms. -5x and -3x, which is -8x. All right. There it is. You've expanded. You can't do anything more with that. Okay. But they got harder than that. Good. I'm glad you think that's easy. Here's a harder version of it. What if the two things you're multiplying have coefficients on their x's? This makes it slightly harder. Certainly the numbers get bigger. But let's try that one. First times first is 6x squared. Outside times outside is 8x. Inside times inside is -9x. And last times last is -12. And once again, as always, the middle things collect. What's -8 of something minus 9 of that something? -1x. And there it is. Then, or sometimes they even do this before. I've taught it both ways. I've taught where I start with this kind of stuff with my grade 10s and then move on to this next one. But I've also tried it with grade 10s where I start with this one and then move on to these later. Do you get that this is the same type of question? We've had this conversation already this year, right? So many people will look at that, even though they've done all their high school math, and they'll say, oh, great, that's x squared plus 9. Because they square the first thing, they square the second thing. You can't distribute a power through a bracket like that. You can only distribute a power through a bracket if everything in the brackets multiply and divide. This bracket's a minus. You can't do that. This is the same as these two questions because it's this thing times itself. So I FOIL again. X squared minus 3x minus 3x plus 9. And again, the middle ones join together. And at this point, or maybe after about 10 of these in your homework, I never tell students this. I hope they kind of figure it out for themselves. You can kind of shortcut this. This always works the same way. Notice that you can take the square of the first thing, and you get that. You take the square of the second thing, and you get that. And then what's the middle one always? What do you notice about the middle one? It's these two terms times together and then doubled. That always works. So if you never noticed that in grade 10 or your teacher never pointed it out to you, let's see if we could do another one by shortcutting it. Let's try it. Let's do x plus 1 all squared. Let's do an easy one. Square the first thing. Square the last thing. 1 times itself is still 1. So what's the middle? 2x, done. Yeah. See, you never have to FOIL that out again if you can remember that. It even works with tough ones. Here, let's do a tough one. let's do whoops, let's have my pen die. Come back, pen. There we go. 2x minus 5 squared. Okay, so 2x squared is 4x squared. Negative 5, careful, this can never turn out negative. A negative times a negative is a positive, right? And then what's the thing in the middle? Times them together, then double it. So 2x times 5 minus 20x is correct. And if you don't believe that, feel free to FOIL it out. That's what you will get, because you'll get minus 10x and minus 10x. Okay, you get minus 20x because you times these two things together, and then you double it. That'll always work when you're squaring. So we could even say, and I'll actually give you this as a formula. If I square any binomial, I get the first thing squared, I get the last thing squared, and in the middle, I get the two things times together and doubled. That's kind of like a formula you can remember. You don't even have to remember it. I'll give it to you as a formula in your formula sheet. In fact, look at your formula sheet that I gave you last week. I think it's on there, isn't it? So that, again, is where you got to in grade 10, but you kept going this time, because in math, anything you should be able to calculate, you should be able to uncalculate. Any operation you can do, you can undo. So just as you don't have to write this down, just as an aside here, let me just go to some blank space here away from the notes. What's the opposite of adding? Subtracting. What's the opposite of multiplying? Let's do something harder. What's the opposite of squaring something? Square rooting, very good. Ooh, here's one. What's the opposite of taking the sine of theta? Yeah, good. Somebody even said the word inverse. The inverse sign. Everything you can do in math, you can undo. So what is the opposite of distribution? If all of the stuff we've been talking about is the distributive property, what's the opposite of the distributive property? The opposite of distributing is factoring. So everything we've done today, we can undo. So let's try doing some factoring review. All right. Oh yes, this elicits groans. Everybody's favorite part of grade 10 was factoring. All right, you know what? Again, let's go back to grade. It's not like factoring was brand new to you in grade 10. You did it in grade 5 or 6. Yes, you did. Because you did those. That's factoring. Yeah, you reviewed it in grade 10. But come on, you did it in grade 5 or 6. Make a factor tree for 42. 6 and 7. And then 2 and 3, right? Remember that? All right. Let's go back now and factor something with algebra. If I have something like, say, for example, how about x squared minus 2x, and I asked you to factor. Well, what's the biggest thing you can take out of both of those numbers? You can take out an x, leaving behind x minus 2. There, see? We just did the opposite of distribute that x. Let's do a tougher one. Suppose we had 6x squared minus 3x. They both have a 3x. Does everybody see that? They can both give you a 3x. So you can factor out 3x, leaving behind 2x minus 1. And again, like I told you at the start, that's where you stopped in grade 10. We never really showed you what that's for. And what it's for is we can solve equations that have those things in them by factoring. We can say that solve these equations for x. And let's say we had the equation x squared minus 2x equals 0. Well, right now you'd probably go, I have no idea how to solve that. But if you look at it and go, but I can factor it, it factors into those two factors, an x and an x minus 2. Those two things times together to make that. I undid distribution. And now I look at it this way. I think if I have two numbers that multiply together to make 0, either the left one's 0 or the right one's 0 or both. Both of them make a solution. So either x is 0 or x equals 2. Because doesn't 2 make this bracket a 0? And then let's try it for the next one. Same thing. We can say we have 6x squared equals 3x. That looks like an equation that would be hard to solve. I'm going to move the 3x over to the other side by subtracting it from both sides. And I'm going to divide both sides of the equation, I'm going to factor both the equation. I'm going to factor the equation by 3, the same way I factored it up here. 3x makes 2x minus 1. And then, okay, this one's a little harder than the last one. This 3 doesn't really matter. What makes this thing 0, if x is 0? But what makes this thing 0? Ooh, that's a little harder to think about. So then I basically say, all right, fine. I'll just solve this equation. What if that whole thing is 0? What x makes that whole thing 0? 2x would equal 1. And x would equal 1/2. And that's my two solutions that I can get by factoring. And that's the part that they didn't really get to much in grade 10, if at all. Why do we factor things? So that we can use it as a technique to solve equations that have x squareds in them. Now, I'm going to caution you against something. Okay, I'll do this in red, because this is not the way I want to see you do your work. Very often, people will look at this same equation and say, oh, you know what I'll do to this equation? I'll divide both sides of the equation by 3, which is totally valid. That works. And then I'll divide both sides of the equation by x. Because I can divide both sides of the equation by a number. If I divide this side by x and that side by x, I get 2x on this side, because x squared divided by x is x. And anything divided by itself should be 1. So hey, I got one of your answers, but I didn't get the other one. There's a very good reason why you didn't get the other answer. What can you not do? Well, what was the other answer again? It was 0. What is it that you can't do with 0? You can't divide by 0. And what did I do right here? I divided by 0. So when you are doing algebra, if you ever get the temptation to, I'll divide both sides of the equation by the variable. Sometimes that gets you a solution. Whoever's playing with their phone should stop, please. Sometimes that gets you a solution, but it'll never get you a 0 solution, and sometimes 0 is a solution. So factoring is always a better option than dividing an equation by a variable. Factoring is the way. All right. Now, this is what we call factor by common factors, right? We had a common factor in here, right? There's an x in this factor, there's an x in that factor. In these two factors, there was a common factor of 3x. Now, let's do the ones that we just saw. Or let's do one similar to the ones we just saw. Solve for x in these guys. Right now you're looking at it going, I don't know what to do with it. In grade 9, they taught you, I'll keep all the x's on one side and I'll move the constant to the other, but that doesn't help you because you can't add together x squared and the 7x. So the goal is to leave everything on one side and 0 on the other and factor this thing. Undo the distributive property. So this is the kind of trinomial factoring that you did in grade 10. You realize that x squared can only be made by going x times x. That's the easy part. But what two numbers times to make 12 and add to make 7? It's 4 and 3. And then once again, now, that's where you stopped in grade 10. Now let's add the grade 11 trick to it. What makes this 0 if x is negative 4? And what makes that 0 if x is negative 3? Those are the solutions to the equation. You can plug them in and check them if you like. negative 4 squared plus 7 times negative 4 plus 12 should equal 0. 16 minus 28 plus 12 does in fact equal 0. That is a true statement because 16 minus 28 is negative 12. Negative 12 plus 12 is 0. The other number should work too. Negative 3 squared plus 7 times negative 3 plus 12 should totally equal 0. And it does. 9 minus 21 plus 12. 9 minus 21 is negative 12 plus 12. No other number in the universe that I plugged in for x would make this thing equal 0. That's it. There's the two numbers that are the solution. So now we know what factoring is for. Let's try another one. Let's try one that looks like it totally should be similar. I'll stick with the 12.
12 and 1.
There you go. What two numbers times to make 12,
And then adds to 13.
but they add to make 13? It's not 4 and 3 this time. It's 1 and 12. Don't forget that numbers are always factors of themselves, right? So this has two solutions of negative 1 and negative 12. Now, are the answers always negative? No, let's do another one like that. I won't bother checking this time. We know the check's going to work. I kind of like that 12. Let's stick with that 12, but this time, let's do that. Okay, so what two numbers times to make 12 but add to make negative 8?
Let me write it down first.
Oh, am I going too fast? Okay, I'll slow down. I'll slow down a bit for you.
Mine goes so fast that you're not even letting any time for thinking on it.
Okay, well, you got to be able to think and write at the same time.
Well, you're going really fast.
All right, sorry if I'm going too fast.
Yeah.
All right, so here's what I'm thinking as I look at that. If two numbers times to make a positive, they could be positive and positive, or they could be negative and negative. But the final thing I add to is a negative. You can't add positives together and get a negative, so I know that it's a minus and a minus. Then I just go, okay, what two numbers times to make 12, but together they make 8, 2, and 6. And now the answers will be positive 2 and positive 6. Because 2 minus 2 is 0, 6 minus 6 is 0. That's where you just, okay, somebody asked, could there be a negative and a positive? You just picked what my next example is going to be. I'll stick with the 12, but what if the 12 was a negative? Okay, sorry, question? No, I don't care. X equals 6, X equals 2, in that order is still the same two answers. All right, let's stick with the 12. I'm having fun with this 12. What if it was negative, though? Okay. So if two numbers times to make, well, first of all, you know it's x and x. Otherwise, you can't get x squared unless you times x by x. But over here, if you have two numbers that times to make a negative, what do you know about them? One of them has to be positive and the other one has to be negative. That's the only way it could work. So now, yeah, now you're thinking, oh yeah, when I add these two numbers together after I FOIL, one's a negative and one's a positive. So I'm looking for two numbers that are 1 apart. Because remember, when you add negatives to positives, you subtract their value. So what numbers could these be? It's a 4 and a 3, but careful. If I put the plus here, which one has to go here? The 3 does. How did you know that? Because they have to add to make negative 1. If you're ever not sure, you could always FOIL again. If I FOIL this out, I should get my original question back. X squared minus 4x plus 3x minus 12. Yep, that works. Okay, so my answers this time, one of them is negative 3, and the other one is positive 4. Yes, the answers can be opposite signs. No, because what makes, okay, we are in agreement that it factors this way, right? So what makes this factor a 0 is my answer to the equation. What makes x minus 4 a 0? When x is positive 4. What makes x plus 3 a 0? When x is negative 3. So that's the way it has to work. All right. Let's see if anybody remembers how to do this one. Okay, I'll put a new instruction down. Factor x squared minus 4. Remember how to factor that? That you kind of factor the same way that we factored the last couple. You just say to yourself that, think of this as x squared plus 0 x's minus 4. So again, I just break it into two factors and say what two numbers times to make negative 4, but when I add them, I get 0. How do you add two things and get 0? That only works if they're opposites, right? One's positive 2 and one's negative 2. And that's what you call factoring. This one's got a special name. This one's called a difference of squares. Well, you'll ace it this time. Okay, let's try another one like that. 9x squared minus 49. Are those two things both? No, they have to be difference. They have to be a minus. 9x squared minus 49. Sorry if I said plus. It's 9x squared minus 49. Okay, are those two things perfect squares? Is 9x squared a perfect square? Yes, it's 3x times 3x. Is 49 a perfect square? Yes, it's 7 times 7. So this is 3x plus 7 and 3x minus 7. I basically did the same thing on this example that I did on the previous one. I square rooted the terms and then put either a plus between them or a minus between them. Question? No. No. As long as you have the both of them, doesn't matter what order you do it in. Okay? All right. All right. Let's jump back to the forward way again. Let's go back to foiling and multiplying and distributing. When we did this, what was it again? Well, let's just do one. Let's do a new one. Let's expand this. So when we expand x minus 5 squared, what do we get? Well, we get x squared minus 10x plus 25. We call this one a perfect square trinomial. Because if I decided to factor it, I'd only get one factor that times is by itself. How can you tell just by looking at it that yes, it's a perfect square trinomial? Because the square root of 25 is 5, and 2 times 5 is 10. So if I had, for example, if I had something like, say, x squared plus 8x plus 16, and I wanted you to factor that, what does it factor to? Can you tell that that's a perfect square trinomial? What two numbers times to make 14 and add to make 8? Aren't both of those numbers a 4? So you can write it like this. because they're both the same. So now let's add the grade 11 twist to it. Suppose I gave you an equation to solve that was x squared plus 6x plus 9 equals 0. Well, again, there's no algebra tool in my toolbox from grade 9 that allows me to solve that. I could move the 9 to the other side, but then what? I can't add 6x to x squared. So I'm going to try factoring it, and when I try factoring this one, I realize that it's actually x plus 3 squared equals 0. Now I can use my opposite rule. How about you square root both sides of the equation? So if I square root this side, it cancels the square. If I square root that side, I'm pretty sure 0 times 0 is what makes 0. So there we go. And then last step, minus 3 from both sides. So that one's a little special. If you hit a trinomial that happens to be a perfect square trinomial, all right, it's time for you to try a few without me. I'm going to just make up 4 of them. One of them will be a perfect square trinomial. See if you can figure out which one it is. And then we'll move on to tougher things. So, first step. Can you do these? Can you do, say, x squared minus 5x plus 6? Oh, I'm sorry, I guess I should give you an instruction. Solve for x. So x squared minus 5x plus 6 equals 0. We're going to solve those. That'll have 2 answers. We'll call that one A. B, x squared minus x minus 56 equals 0. C, x squared minus 4x plus 4 equals 0. And D, we'll try to keep the number small here. X squared, oh, that's a terrible looking square. Let me fix that. X squared minus 3x minus 4 equals 0. So there we go. I'll give you 4 of those to practice. I'll do attendance while you do that. I'll pause the video so that anybody who's watching this on video can try this at home and pause it for yourself and give those a try. Okay, and we're back. So here we go. What 2 numbers times to make 6, but they add to make 5? It's 3 and 2, and they both have to be minuses because this is a minus. So it's minus 3 and minus 2. So x is 3 and x is 2 are my solutions. Okay, next. What 2 numbers times to make 56, but one of them's positive, one of them's negative, so they add to make negative 1, which means they're 1 apart. 7 and 8. And who has to be the positive? The 7 does, because it has to add to make negative 1. So my 2 answers are x is negative 7 and x is positive 8. All right? I told you one of these would be the perfect square one. It's this one. Because this one factors to be x plus, no, sorry, not plus, x minus 2 squared. It ends up being negative 2 times negative 2. So this one I'm going to do by square rooting both sides of the equation. And then x is equal to 2. 2 is the number that if you plugged it in for x, you'd get 0. And then, last one, what 2 numbers times to make a negative 4? So one's a positive and one's a negative. But they add to make negative 3. This time the 1 is the positive and the 4 is the negative. So my answer is negative 1 and 4. All right. Now, this stuff gets one step harder. What if the thing that you are factoring has a number in front of the x squared that isn't a 1? Well, sometimes you can factor it out completely. So let's try this guy. Solve for x. And let's say we had 2x squared minus 2x minus 24 equals 0. So what do you notice right away about that? You should notice that the first thing you always look for when you're factoring is, do I have a common factor I can factor out? Notice all of these numbers can be divided by 2. So I'm going to divide out a 2 for all of those numbers. And hey, I think we've seen this one today. It's 4 and 3. Minus 4 and plus 3. Equals 4. So there's my 2 answers. Okay, now, that's the easy way to do it when this is a 2, or when there's a number here that isn't a 1. Suppose I started with one like, well, how about we go back to this one? Let's go back to one where we kind of know the way it's supposed to turn out, because we did it earlier. Suppose we had a 6 in front. And now, okay, look at that one. Can I divide everything by that 6? Not easily. I mean, I could divide this one by a 6. I can divide 12 by a 6. But if you divide this 1 by a 6, you're going to have a fraction. Nobody wants to work with fractions here. If I tell you that for sure this is factorable, there must be a way to do it. Okay, so we're going to roll back here. Actually, I'll just rewrite it. This was the example that we did back here. I think it was the second or third example we started class with. That is what is ending up making this thing. Now, when we foiled it, and again, sorry if there's people who didn't call it FOIL in grade 10, when we expanded it, when we used our distributive property, we got 6x squared plus 8x minus 9x. Oh, wait a sec, something's wrong here. Oh, you know what? This should be a minus. Did I put this as a plus when we did it? I did. Well, I did in my notes anyway. There we go. That should be a minus. My bad. Okay, and then finally, last times last is negative 12. Okay, when we were simplifying, we just added 8x to negative 9x and went on with our merry lives. But I'm going to show you something that you probably never noticed, even though you probably did dozens of examples just like this in grade 10. Here's something to notice that's really cool, and it's going to help us factor that thing. What's 6 times negative 12? Come on, you know your 12 times table?
72.
It's negative 72. What is positive 8 times negative 9? It is also negative 72. That is always something that's going to be true when you hit this stage of an expand problem, where you're expanding a binomial. Try to stay focused. So, we're going to use that trick, that fact, to help us factor this thing. We're going to say, we know 6 times negative 12 is negative 72. Are there 2 numbers you can think of that times to make 72, besides 6 and negative 12, that are 1 apart, that would add up to negative 1? And if you know your times table well, 72 is 8 times 9. Your teacher in grade 10 called this the decomposition method. Maybe that rings a bell? I'm decomposing minus 1x into minus 9x plus 8x. And then, notice now I'm kind of at this spot. Now, how do I go backwards from here to here? It takes me 2 steps. I look at the first two terms here, and I look at the second two terms here, and I try factoring by common factor. What is the biggest common factor in 6x squared minus 9x? Well, they both have a 3x in them. And if I factored it out, I'd get 2x minus 3. What's the biggest thing I can take out of 8x minus 12? Well, they don't both have an x, but they both have a 4, right? There's a 4. When you count by 4s, you'd hit 8. You can count by 4s, you'd hit 12. So if I take out a 4, what's left out of these things? And check this out. Is this starting to come back to you from doing this in grade 10? And there's your two factors. I can now factor this thing here as if it's its own number. Factor it out, and it's 2x minus 3 times 3x plus 4, and that's what we started with back here. So we know that's true. Now, this does have a little bit of trickiness to it in our last step. Remember, my instruction wasn't factor, my instruction was solve. What makes this number a 0? Ooh, I don't know. How about let's solve it in C? What makes that number a 0? So I'd add 3 to both sides, and I'd divide both sides by 2. The answer is, if you like decimals better than fractions, 1.5. Let's do this one. Did I lose you in this step? Again, I have to figure out what makes this a 0. And it's harder to do than the last ones, where it's just, oh, x minus 3, so I guess x is 3. What makes this a 0 I can find by solving for x when I literally set it to 0 using algebra. So 3x plus 4 is equal to 0. So 3x is equal to negative 4. So x is equal to negative 4/3. And again, you could use a calculator to figure out what that fraction's decimal is if you needed to, but I know it. It's 1 1/3, so it's negative 1.3 repeating. Okay, I'm going to be a far kinder, gentler math teacher than your grade 8, 9, and 10 teachers were. Because let's show you what this is for. In fact, this course is what this is for. Why do we have to be able to solve equations this way? What is the point of this? Well, remember, quadratic equations graphically are parabolas. So everybody caught up to, oh, why did that go like that? Okay, well, everybody caught up to there? I want to go to Desmos for a sec. Okay, I'll give you a sec. That one's ugly. That's a tough one. That's as tough as these get. If you can do these, we'll never be able to stump you.
So it's like the quadratic forms don't make it more easy?
Quadratic formula we do next. Somebody's asking about the quadratic formula. That's next. We do like to be able to factor ones that do factor. Quadratic formula we can use for ones that don't factor. This does factor, as ugly as it looks. Okay, really quick before we run out of time, I just wanted to show you, and we'll just continue the lesson here tomorrow. I just wanted to show you what these look like on Desmos. And on Desmos, if I had the equation y equals 6x squared minus x minus 12, it's a parabola, as you can see, and look at that. Negative 1.3 repeating, and 1.5. That's why we're doing this stuff. Okay, we're out of time. We'll pick it up there tomorrow.